Hey, how's it going, everybody? It's your boy, Delightful Kiss Boy, and today I'm back with some more coding. Yippee! If you like that kind of thing, you're in luck. If you don't, sorry, we're doing it, alright? Now, I'm not going to continue on with the Clover Pit stuff yet, because I was thinking about it, and it's like, I think I've done enough work on it that I'll be in a good shape when the game comes out, and there may be mechanical changes over time. So I don't really want to go full in on the demo mechanics. So I'm like, okay, I'm going to put that on like pause. Maybe I'll continue doing videos when the full game comes out and I can look at the mechanics and then try to simulate that, you know? But now what I want to do is I want to start a card counting project, all right? Gonna be in C# like usual. I gotta learn how to do Rust, man. I wanna learn Rust so I can code in that, because I've used Rust a little bit and it's kind of a delight, honestly. So I got to get back to that at some point. But just C#'s the language I'm most comfortable with right now. But yeah, I want to do some card counting analysis. People have been asking me to do it for a while, so I figured, hey, I'll just start the code at least. Let's see what happens. And I want to make sure I, do it right. So let's see here. Let's do new project, and let's do a little console app, and let's call it card counting analysis. There we go. I guess I started a while ago. Let's do Blackjack analysis. There we go. All right, Blackjack analysis. So I must have started a project a long time ago, but then I didn't keep up with it. So let's just go ahead and start fresh. I just want to start from the beginning so you guys can see new update available. Don't care. See what I'm thinking about this. All right, so let's do some planning just initially, right? So basically, I'm gonna need a deck. Well, okay, let me just start with the data structures. I mean, like, if there's some obvious data structures that I'm gonna need, it's kind of nice to just start off with that kind of thing, and then while I'm implementing that, I can kind of start to think about how the rest of the stuff is gonna look. Let's just get our basic data structures out of the way. So, public class, program, let's just change this. Public, doesn't really need to be public, it's just the entry point. Let me just rename this also. It's gonna be Blackjack analysis main. This will just be the entry point. There we go. Okay, we'll come back to this here. Now, what I want to do is, let's just comment. I'm going to try to comment more too. So, entry point into the Blackjack analysis program. All right, now, my policy when it comes to commenting, by the way, is like, I try to comment most methods and properties, but like, I want the code to usually be, self-explanatory, and usually you can achieve that by just dividing things up enough. But anyway, so we got our main. Let's make our cards and our deck to start off with. So let's do enum to start off, because we're going to be doing the following. So let's do suit. There we go. Root namespace. Public enum. Actually, we need an enum. Once again, enums are just kind of named integers, essentially. I want to do it in suit order. Let me see, making sure I'm still recording. I am recording. Okay, we're good. Let's see. So, playing cards, suit order. Clubs, from lowest to highest, clubs, diamonds, hearts, then spades. All right, let's just do it like that. Clubs, diamonds, hearts, spades. Doesn't really matter, but I don't know. I like to be clean with it, all right? I'm just going to say, represents a suit of a standard playing card. Ultimately, we don't really need suits with, blackjack, but I don't know, if I want to turn this into like a game or something at some point, or have a visual thing, I might as well keep track of it. It's not going to take up too much, it's not going to be too much trouble. So let's just do that, and then let's do rank as well. All right, so rank here, public enum rank, there we go. Represents a rank of a standard playing card. Okay. And let's just start from the bottom. Should I start with ace or should I start with 2? Let's start with 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. There we go. All right. So we got our rank enum as well. Let's make a card, a very basic card data structure here. So new folder, let's call it, let's have a folder for like card related stuff. So I'm just gonna put card here rather than calling it models. So let's do this. So card, it's gonna be a very basic data structure that just has a rank and a suit basically. So public class card here represents a standard playing card. I'm not including jokers playing card because there's no reason to. If I need to go back and make like a Pi Gao thing or some shit like that, I'll do that. Anyway, card. So let's just have it do public punlick. Public. I'm gonna use this. I got a boom mic stand, but it's like over my keyboard. It kind of leaned over. Let me just get this squared up now so I stop making so many typos. Public suit. I guess rank first. Rank, rank, and we'll get it. And public suit, suit, which we'll get as well. Let's put a default not a default constructor. Constructor up here. Rank, rank, suit. Suit, we'll keep it immutable here, and so equals rank, so you can only get, you can't set. There's no reason to have these be mutable. Alright, let's say the rank of the card, the suit of the card. Alright, that should be about all I need on a card, I believe. I could do a 2-string as well, actually. Yeah, let's just do that, so it'll make it easier later. So public override 2-string, string, 2-string, yeah. I don't even know if I need to write this. I don't need an explanation for 2-string. Everybody knows what the fuck that is. Alright, so it's just going to be this. Let's do rank, right? So this dot rank of this dot suit. There we go. All right, so we got a 2-string method. We don't need, we could do equality as well. I'm not gonna need that yet, so I'll come back to that. We don't need any hash functions or anything like that, do we? We'll come back to it if we need it. We don't necessarily need that shit. All right, so there we go. We got our basic card here. Next thing we want to do is have a shoe, I believe. So I'm not gonna do a deck because ultimately, a shoe and a deck are basically the same thing. So we're going to have a shoe. The shoe is just multiple decks stacked together. All right. So here we go. Shoe. It's basically going to be a collection of cards. All right. So public class shoe represents a shoe of standard playing cards. All right. So what the shoe needs is a collection of cards. So what are we going to, how are we going to store that? We could just do a list of cards, right? I mean, we don't need to really get fancy with it, do we? Yeah, so private list cards, right? So I have a list of cards. We'll pop off the back of it so that we're not moving the elements in the list. Should be fine. Somebody told me that this is more efficient than a linked list anyway, and I'm inclined to believe that. So I think I did a prior implementation where I was using a linked list, but I think if we just instantiate a list and then always pop off the back, it should be fine. Yeah, I mean, I'm not going to overthink it. It should be fine. So we have a list of cards. Also, we can shuffle it. So I need to... Let me just do this right now, by the way. I always copy and paste. C# shuffle list. I was going to Stack Overflow and copy off the fucking basic bitch shuffle algorithm here. So the question is, do I want the... Yeah, let me make it a an extension method. Well, we'll come back to that. I've got the page up. Anyway, we got the cards. Let's stay focused on what we're trying to do. I mean, what else does a shoe need? Shoe needs a cutoff point. Do I need to have that in the shoe? So, like, usually when you're playing blackjack, the dealer will shuffle together the shoe, and they'll place a cut card somewhere. Does that need to reside in the shoe, or do I want that to reside somewhere else? I mean, it could be in the shoe. The thing is, that just tells you when you need to reshuffle. Do I want that to be handled within the shoe? The thing is, if we're doing card counting shenanigans, right, we need to be aware of when the shuffle happens, so we don't want it to be automatically done in the shoe, I don't think. I think that we want to have that be a separate step where the game sees that the shoe is below a certain threshold and then shuffles, and then we'd have a chance to respond to that shuffle and like reset our count, for example, right? So I think that it makes sense to just have the shoe have very basic functionality, basically just be a stack with which will then take a shuffle, have a shuffle method that's called externally. No auto shuffling. Yeah, let's do that. All right, so in that case, we just need cards, and we need, for true count stuff, we're going to need a count, right? So a remaining number of cards. Because, I mean, we don't have to, like... I'm not going to fuck around and be like, oh, we need to have a data structure for keeping track of that shit. I'm just going to make it so that we can always reference the shoe and get the info we need. So, let's just do this. So, public int num cards, and then we'll do get and return this dot cards dot count. Right. There we go. Pretty simple dimple. Okay, so let me just comment this out. Gets the number of cards remaining in the deck. Because we, I'm trying to think here. When somebody draws a card, we want it to be removed from the shoe. Yeah, that should be fine. Yeah, that's all good. That's all good. Okay, we're good. All right, and then this is going to be the cards, in the shoe. There we go. The cards in the shoe. Okay, there we go. It's like self-explanatory. I just got in the habit of doing this. Like basically style guides and things like that tell you to comment every method and thing. It's fine. Anyway, but let's do this. So public, we want to just have references to, do we want to copy everything? Trying to think here for how we want to take in this data. All right, let's just do this. So public shoe, and do we want to take in an enumerable? Yeah, let's do that. So I enumerable cards, and then we'll do this dot cards equals new list card, and then we'll say for each var card in cards. This dot, let's actually instantiate it with cards dot count. So basically, we will basically pre-allocate the list to have enough capacity for all of the cards. So we're not, it's just a little bit more efficient, I guess. All right, so this dot cards dot add card. Easy enough. All right, there we go. All right, so we have now instantiated all of this stuff, and then we need a let's do this. Initializes a new instance of the C cref shoe class, and then the cards to put in the shoe. Sure, whatever. All right, so there we go. So we got our shoe constructor here. We need a draw function. So public card draw. And then we will just var. I think let me see. Does list.remove return anything? So this.cards. This.cards.remove returns a bool. It just does a bool that remove at. That's a void. Yeah. So okay. So we're gonna need to get the actual one. All right. So here we go. So var card equals this dot cards dot of this dot. Let's use the property. It's fine. I mean, it's doing this -1 because it's 0 indexed. And let's do this. Var last index equals this, because we're going to be reusing it in a sec here. Last index, and then what is it? This dot cards dot remove at last index return card. There we go. All right. So you say draws. So removes a card, removes the top card of the deck and returns it. Returns the card draw that was drawn. All right, there we go. So we got a draw method, and this can also be used for burning. So I'll just have the same sort of logic where they burn a couple cards at the beginning, that sort of a thing. Now the question is with shuffle. Yeah, we can just put the shuffle in here. Why not? All right, so public void shuffle. Doesn't need to take any parameters here. And let's just do, I'm just gonna copy this from fucking Stack Overflow, baby. That's how you do sometimes. All right, so this dot cards dot count. Let's just change this to this dot num cards. I don't know, there may be some kind of fucky logic later that would change that. Probably not, but it's all good. So while n is greater than 1, you subtract 1 from n, and then you get a random number generator. Oh yeah, we need a random number generator. Do I want the... No, let's have the shuffle take a random object, actually. So that way, I don't know if I want to test this. Dependency injection works a lot for testing. I could pass it into the constructor of the shoe, but there's like... It's not necessarily... You're only going to use it if you're shuffling the deck. It really doesn't matter either way. It's fine. Maybe I should just pass. Should this have its own RNG? I don't think it needs it. No, let's just take it there as a parameter. It's fine. Anyway, let's do var value. It's generalized on the thing here, and then this dot cards. Okay, this dot cards. Okay, just gonna copy this. Be a little more efficient about this. There we go. So it's basically just swapping shit around. What is this saying? Use tuple to swap values. Sure. Wait, why is it saying that? Use tuple to swap values. There we go. All right. A little bit of an IDE optimization. All right, let's comment this. Shuffles the deck using Fisher Yates. Actually, that's exposing implementation details. Shuffles the deck. All right. The random number generator to use to shuffle the deck. All right, so we've got our shoe. I think this is all we need to do, right? We construct the shoe, we draw from the shoe, we shuffle the shoe. That's everything you do in Blackjack. So, should be fine. Okay, so we got our cards, we got our shoe. What else do we need? What else do we need? Probably hand, right? Well, let's come back to hand. We'll start the scoring logic and come back to hand in a bit. So let's do this. So those are card-related things. Let's talk about what do we need to do. So we need to, basically we need to have a hand of cards and we need to be able to score a hand of cards. Basically, give us the number that it adds up to, and then there's the kind of complication when it comes to aces, where aces can either be 1 or 11. So we want to get the best score possible. So where should that logic reside? I think it could just be a utility method, static method in a library that, where do we want that to live exactly? I'm just trying to think. It could just be in a scoring utils. I'm trying to think of what else would live in storing utils though, right? It's basically to score a hand. I mean, there might be something that pops up. Let me just put it in the base directory. I mean, once again, I'll organize later. So we're going to do scoring. I don't like the term utils. Let me think here. So scoring, I mean, I don't know. It should be fine. Scoring utils. Who gives a shit? It's fine. I'm being picky right now. Public, pinblick, static class, scoring utils, collection of functions related to scoring hands in Blackjack. There we go. All right. So let's do public static int score hand. Now let's think about what we want the hand to be. Do we need the hand to be a specialized object, or can it just be a list of cards, is what I'm wondering. I'm just trying to think here. So what do you do with a hand? What do you do with a hand? You draw into the hand. You get cards. I mean, the thing is, like, I'm inclined to make a hand object because it's, like, lower risk. Like, if it ends up just being a wrapper on a list, that's fine, you know? And it also explains to the user, like, what... Yeah, let's just make a hand class. Let's go ahead and just do that, then. So, let's do that. Don't really care if this just ends up being a wrapper on a list. It's fine. Alright, let's do that shit. Public class hand represents a hand of Blackjack cards. And then we can have specialized functionality like splitting, for example. Maybe I could even have something where it's like, is splittable as a method. Yeah, we could do that. Although that depends on the rules of the game, too. Whether there's like a max number of splits, and if you're allowed to resplit aces and stuff. So that would be dependent on the rules. So we would probably want that not to reside in the hand, but okay, it's fine. Alright, so here we go. So what does a hand have? It has a list of cards. It's another shoe. Alright. Public list card cards. Jesus, cards right there. But I could also have like sorting stuff in here too. Should be fine. Cards, let's think here. So we could have a default constructor that just instantiates a new list. And then we could just add one at a time. Alternatively, it could, yeah, I don't think we're ever, let's just do this. So we'll have a default constructor. Public, hand, doesn't take any parameters. This dot cards equals new list card. Simple, alright. So let's go ahead and do this. Cards in the hand. And then this will be initializes a new instance of the C. God damn it. Hand class. This is for like, what is it? When you do, it's like a markdown kind of thing, I think. It's, I don't know. It's fine. Anyway, so we got a new list of cards here. Let's think here. So, yeah, fuck it. Alright, so let's do public void add card and card. Alright. I don't even need add card. What else are you going to be adding to a hand? Add, and I'll take a card as a parameter. There we go. Add. Okay. So we add a card. Yeah. This dot cards dot add card. There we go. Adds a card to the hand. The card to add. Alright. There we go. So we got an add function there. Now, do I want to get ahead of myself and get into the split functionality, or should I just wait on that? I could do it. Yeah, let's go ahead and do it. Fuck it, why not? We'll have it, okay, so I'm going to make it so that this handles splitting, but, other things will handle determining if you can split. So this will just assume that you can always split the hand. So let's go ahead and do that. So let's say public hand split. So basically what I want to do is I want to remove the card from this hand and then return the new hand with the additional card. There we go. All right, so split. And now here's the thing. Do I want to have logic in the split function to validate that we only have 2 cards? Or do I just assume that when we're calling that... Well, okay, let's do it like this. So, we'll have an isSplittable method, but then that needs to be, like, that's independent of the rules of the game. It just returns if both cards can be split. Actually, so that's a good point, though. I need to come back to that. Let's go back to our scoring utils function, actually. So let's actually come back to this too. So score hand, we'll handle this in a sec here. We'll to hand, and then throw new not implemented exception right there, because we're not getting to that one yet. The thing I want to do first of all is public static int score card. There we go. Card. So this is going to return the score of the card. So we're going to swatch. God damn, dude. I'm terrible at typing sometimes. Card dot rank, and then case rank dot 2. Return 2. Case rank dot 3. Return 3. I have to do all this shit. Case rank dot 4. Return 4. Case rank dot 5. It's always fun using enum sometimes. Return 5. Case rank dot 6. Now you may be wondering if there's a more efficient way I could do this. I mean, I could technically make it so that the enum values are equal to the score, but the problem is that we have king, queen, you know, jack, etc. And I could make it so that it's like if it's 2 through 10, then we just return whatever the associated value is, but should I just do that, actually? Yeah, fuck it. Why not? Let's go ahead and do that then. Let's do that. Okay, so we're gonna do this. So 2 equals 2. 3 equals 3. 4 equals 4. 5 equals 5. 6 equals 6. 7 equals 7. I mean, it doesn't really matter. We would have that utility method and we'd never be looking this up manually, but sure, dude. Alright. 10 equals 10. We'll have these ones just kind of be special though. So 11. 12, because these have to be unique values. 13. 14. Okay. Let's do it like that. And let's say... scoring utils, let's do this instead then. So, if int card.rank is less than rank int less than or equal to int rank.10. Actually, I don't even need to cast that then. If the rank is less than rank.10, less than or equal to that, then return the integer version of card.rank. And then otherwise, switch card.rank case ace or rank.ace will return 11 in this case. I mean, of course, it can be a 1 also, but we'll handle that later. Default return 10. So basically, this should handle 2 through 10. This should handle ace and all of the face cards that are all worth 10. All right, should be fine. All right, so let me see. Gets the score of a card. Note that 11 is always returned for ace. All right. The card to score returns the score of the card. All right. I mean, I could... Nah, we'll have a more specialized method there. This is just going to be a basic one. All right, so let's go back to our hand here. Let's get to this one here. Public bool can split. So this will tell you if you can split your hand. So let's see here. So if this dot cards does not equal 2, return false. Or count does not equal 2. So basically you need to have 2 cards in your hand, and then return scoring utils dot score card, because you can split like a jack and a queen. All right, score card this dot cards of 0 equals scoring utils score card of this dot cards of 1. There we go. So if we don't have exactly 2 cards, return false. Otherwise, if the scores of the cards are the same, then we can split our hand. So I'm going to assume... Okay, let me see. Let's put this. So, gets whether or not the hand can be split, not taking rules into account. Not taking splitting rules into account. Specific splitting rules into account. There we go. All right, so returns true if the hand can be split. False otherwise. There we go. All right, so now we have the split function, and this one is going to say splits the hand into 2 separate hands. Yeah. Do I want it to throw... No, it's fine. Whatever. We'll just... into 2 separate hands, assumes the caller checks to see if the hand is splitable. There we go. I'll just put that down. Alright. So returns the new hand created by the split. Alright, there we go. Alright, so what we're going to do here is we're going to say var new hand equals new hand. And then this, so new hand, let's do it. Var card equals this of cards of 1. And then this dot cards dot remove at 1. There we go. And then new hand dot add card, and then return new hand. There we go. All right, so we got a hand. The hand can be constructed like this. You can add cards to it. You can split the hand, and then that's all you can do. Okay? Now we're going to go back to scoring utils. Ooh, wait, I need to be able to enumerate through the hand as well. So let's make this a numerable card. So I enumerable card. We'll see if we can just get away with the enumeration. And should I make it indexable as well? Not really. I don't think we need to, right? But we'll come back to that. Implement the interface here. Return. Get enumerator. Why is this then down here? Oh, fuck it. Whatever. It doesn't matter. Let me... Why did it put it like... Why did it sandwich this one between those two? Is there something I'm missing here? Nah, whatever. I'm just going to put this down here. Alright, moving you down here, just so these are next to each other. And let's go ahead and return this dot cards dot get enumerator. Same with you, buddy. Alright, there we go. Gets the enumerator for the cards in the hand. For cards in the hand, returns the enumerator. Sure. I'm just going to do the same thing down here. Alright, so now we can enumerate through all the cards in our hand here, which is pretty nice. And so let's go back to our scoring utils here, and let's do it like this. So, var score equals 0. And we just go through all the cards, right? So for each var card in hand. And here's what we want to do too. We need to keep track of how many aces there are, right? Or no, we just need one ace, because you can never have two soft aces in your hand. So var soft, or has ace. Num aces. No, we just need... It has ace equals false. So let's do it like that. So we're going to say that there's no ace so far. For each card in hand, if card.rank equals rank.ace has if has ace, so if we've already seen an ace, then score plus equals 1, because you can only have one soft ace. And then we'll just say has ace equals true. Else score plus equals 11. Let's do score card. I mean, we don't need to do that, though, right? We can just do that. That's fine. Yeah, I don't know. It's fine. It should be fine. This is mostly just to check for splitting shit anyway, and then it'll work for the other cards. So if we have an ace already, we add 1. If we don't have an ace, we'll add 11. We'll come back and revisit this if we go over 21. But then for all the other ones, so basically else, then we just handle it pretty easily. So score plus equals score card with card. There we go. So pretty simple right there, right? So we have score equals 0, has ace equals false. If has ace, score plus equals 1, otherwise plus equals 11. And then if score is greater than 21 and has ace score minus equals 10. So we'll make the ace hard. We'll make it hard ace, right? So basically, if our score is above 21, score is greater than 21, and we have an ace, then we know that that ace, one of those aces, has to be soft. So we subtract 10 to make it so that it counts as 1. And then we return the score. Alright, that's it, right? So score equals 0, has ace equals false. For each card in the hand, if we have an ace, we add 1. Otherwise, we add 11. And we say has ace equals true. And then we add just all the other ones normally. And if we have more than 21 and we have an ace, we subtract 10. We return the score. Alright, that should work. Alright. So, scores a given hand in blackjack. There we go. Hand to score the score of all cards in the hand. Alright, so we've got our scoring function. We've got our hand here. And that's a lot of the game. So now, here's what I want to do, is I want to, what do I want to do here? So we got most of our data structures out of the way. How do I want to structure this? So let me think now. So I can implement the game. And we will have a game that can have a certain number of players. And the players will operate based off of certain strategies. So here's what I'm thinking, right? The way I want to do it is like... Because here's the thing, we're going to be counting cards, and so the way that the people that play around you affects how you do. It'd be interesting to look at how that affects it. So basically, I want to take a set of players... And the players can all play differently. Because it'll be interesting to analyze if the way that people play impacts your chances. Like, I know that obviously if you're following basic strategy, it doesn't matter. Like, there's a myth that it's like, oh, if you play poorly at blackjack, then it fucks people over around you. That's a myth. But if you're counting cards, there's legitimate... Like, basically, the more aggressive people play around you, the better, because... then you get more information, I think. I would guess. So yeah, I do want to... So basically, okay, I want to construct a game that takes a certain set of rules, right? That's another thing you should do, is have, like, settings where it takes in a certain set of rules that determines how the game functions, right? Like, number of decks, that sort of thing. You know, if you can resplit aces, all that sort of nonsense... in a list. Then I should have different players that can have different AIs. And then I should have the dealer, and the dealer basically does the same thing, except there's the difference between if he stands on a soft 17 or hits on a soft 17 and that sort of shit. Yeah, and yeah, okay, so let's go ahead and do that then. Actually, I gotta take a break. I gotta go to the bathroom real quick, so I'll BRB. Alright, we are back. Man, that coffee really goes right through you. But, a couple things I want to do. First of all, I thought about it. I want to move this enum folder into the card folder. So this will be card-related enums, because I think I'm going to need other types of enums, and I'll put those in the corresponding folders. So basically, yeah. So, as I was saying earlier, what I want to do is have the game take a certain... set of players that each have their own behaviors, and then, yeah, basically set of players, any number, play out the game, and then the dealer just operates. So basically, okay, let's make a game folder here. So let's do this. So we're gonna go with game. I'm going to move the scoring utils into the game folder here. And then what I want to do is... Actually, let's have a player folder as well. So let me define what a player does. It's a player here. Okay? So... a player is going to take a certain number of actions. It's going to be an enum. So what I want to do is have one called player action, right? And I mean, the dealer can kind of do the same shit, so it's just going to be, yeah, we'll say player action. That should work. All right, so player action. And now, what are the different actions that you can take? So public class player action, or public enum, actually. Public enum player action represents all possible actions in the game of Blackjack. All right, so these are going to represent all of the different actions you can take. So we're going to have stand be our first one, hit be our second one. Those are the basic things. So stand and hit, and then we got to get to the rest of the bullshit, right? So stand, hit, double down, split. Ooh, actually, let me put surrender up here. Surrender, double down, split. Am I missing something? Is that all you can do? Stand, hit, surrender, double down, split. I guess I can put insurance here as well. Insurance. Because insurance is when you're betting that the dealer has a blackjack. I don't know if... Do I want that to be a normal action? I mean, these actions are all, like, taken... This is giving you a separate side bet. But I don't know. I think this should be fine. I can go ahead and change it later if I need to. So, stand, hit, surrender, double down, split, insurance. There's nothing else, right? I think that's everything. All right, so these are all the different actions the players can take. So let's come up with an interface for what we want our player to look like. So this is going to be iPlayer, which is an interface here. Let's go ahead and get rid of that shit. Public interface iPlayer. Now, what does a player need to do? Let's say represents a player in the game of Blackjack, not the dealer. All right. There we go. So player should... So I'm kind of going to jump around here because I'm going to be doing a little bit over here and then going back and doing some other shit, I think. So what does the player need to do? The player needs to be able to give the game an action to take, right? Yeah, so let's do this. So action, get action is going to be one such method. We'll figure out what we need to pass to it in a bit, because it's basically going to be like I need to pass it the game state. Here's what I'm wondering though. Do I want to divvy up? No, I think I'll pass a single game state object to the player that will have all of the stuff that they could need in order to inform their decisions, right? Get action. Okay, now here's... Okay, let me just think though. Let me think though down the line. All right, so with basic strategy, this should be fine, right? Basically what you do is you just can take the state of the game, so basically your hand... that's the other thing. Should I have the player have a hand? I don't think I should. I think I'll keep that separate from the player. So basically, I'll have the game keep a mapping of player to hands. Also, so that should be int ID get. So players should have IDs. Do they need names? Do I want to get cute and have names as well? I mean, to make for a better video, potentially. But for now, I'm just going to have IDs, all right? So basically, each player needs to have an ID, and they need to be able to return an action that they want to take. The hand mapping is, I think, going to be handled by the game. Because here's the thing, I don't want to put that in the player because it's going to have to be refreshed like every round anyway. So like going in and changing the state of the player doesn't really make sense, you know? So I think instead we'll have the player be representative of like the behavior of a player, not necessarily like the state of a player, but it'll have the ID so we can use the ID to map between the state later and the behavior, right? So, and then the thing passed to the player will be the game state, and then the player would be able to find their own hand within the game state and use that to determine whatever. The thing I'm wondering about, though, is with the card counting logic, right? So, how do I want that to work, right? Because the card counting players will essentially be having different mechanisms to keep count. So I think that there should be like a notify method. Maybe, okay, we'll get to that when we get to that, but I just want to have it in mind for how I'm going to structure the game, right? So basically, I think I don't want like an eventing mechanism where the game has like a feed that people, I want like a push-based notification model so I don't have to deal with the fucking eventing shit. And since I'm doing this from the ground up, I can do it whatever way I want. So instead, I think what I'll eventually have is like a notify card revealed method on each player. And then the basic strategy players don't have to do anything, you know? But then the card counters, they can get that notification and update their own card counting logic, right? Their own card counting state, right? And then I'll have like certain things that have, or, you know, count cards perfectly and yada, yada, yada. So I think that'll be fine. Let's go ahead and keep it like this for now. So eventually I'm going to be passing in the game state here, but I haven't created that yet. So gets the ID of the player. And then this is going to be gets the action of the player. Actually, I'm going to comment this later because it may change over time. So here we go. So we got get action, we got players, now we got the game. We put scoring utils in the game folder here. So now what we want to do is, let's just call this one game. All right, so we're creating our game class. And I think the game class will be public class game, just like that. Represents a game of blackjack played at a single table. All right, so we have our game class, and now the class is going to need to have rules passed in. I want to use dependency injection there, so it'll take in a set of rules. So there we go. So we need game rules as well. So where do I want to put that? Let's just do it here. So game rules. Let's create that class as well. I'm just kind of getting everything outlined right now. So public class game rules here. Game does rule, baby. All right. Represents the rules of a particular game of blackjack. All right. So let me bring up a list of fucking things that I should be open, just in case I accidentally end up recording this. I should open up this other Chrome thing. All right, I don't want my name to get leaked. All right, here we go. What is it? Blackjack rule variations. I don't know, something like that. Blackjack rule variations. Here we go. Wizard of Odds, my goat, my goat. Rule variations will have an effect on the player's expected return. The numbers below affect the blah, 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 blah. All right, there's a lot of shit. Okay, so here we go. Blackjacks pay 2 to 1. Yeah, don't play anywhere that doesn't give you 2 to 1. 1 to 1. Holy shit. That's bad. Okay, so triple down on any 2 cards. Triple down? Wait, what's 5 card Charlie? So I'm getting distracted by this now. Automatic winner Charlie rule in blackjack. Rarely in blackjack there's a rule that if the player reaches a certain number of cards, usually 5 to 7, without busting, the player will automatically win. This is called Charlie. Ooh, that's really cool. Okay, okay. Triple down on any 2 cards. I haven't heard about that shit. Alright, so there's a lot of shit in here. For now, actually, I'm going to leave this blank for now. I'll probably do some more research on my own time. I mean, this is my own time. I'm just recording it for the channel. But I'll do some more research, try to understand the most common variations, and then get that implemented here. For now, I just want to make sure we're passing it to the game class, right? So let's go ahead and do... so the rules are going to be immutable. These will be immutable. Well, no. I mean... There's going to be a lot of them, so they should be mutable. I'm just wondering how we would want to do that. If I wanted them to be immutable, I could have kind of a factory object that creates the game rules, because I don't want to be passing, like, 50 million parameters to it. The thing is, like, it doesn't make sense to change the rules mid-game, so they should be immutable. So maybe I should have factory object that helps construct the rules over time, and then sets them in stone. I mean, it doesn't really matter though. This is just my own personal project, so I could just have them be mutable. Yeah, I don't fucking care. It's fine. But for now, I'm just gonna pass it into the game. All right, so let's go ahead and do this. So public. It's also gonna need a random number generator. So let's do that. So private random R. Private, not public, because we want to be returning the rules. So public game rules get. So that basically players should be able to see what the rules are. That's why I want to be immutable though. So maybe I will make a factory pattern just in case. I don't know. Why am I thinking about this? Sometimes I overcomplicate this shit. So we got private random R. We need the so private shoe, right? Well, okay, maybe I should do this. Let me divide out the state actually. So. We'll do this. We'll do game state here, right? So game state. Okay. And the game state is going to have all of the shit that is available to the players. Okay, so let's go ahead and do this. So represents the state of a game of blackjack. I'm trying to think. You should be able to reconstruct a game from the game state. Theoretically. So actually, no, let me think here though. Do I want this to be, this should be all of the state that is available for the player to read from. So it should be like dealer up card. I could also, so I'm trying to think. Do I want to enforce it so that this view... Yeah, okay, let me have a game state view, and then let me have... Or sorry, a game state, and then have a game view. And the game view will be everything that's available to the player to see. So there's going to be game state, and then game view. Let's do that. So game view. Okay. So let's start off with this. So public class game view represents all information available to a player. All right. I think that should be good. So this will have public card, dealer up card, get. There we go. Dealer up card, get. Trying to think. We will assume that if a player wanted to know how many cards were in the deck, they would have been keeping track of that. So that should be available. So public int num cards in deck, get. Public iDictionary int hand player ID to hand get. So they basically, you can see what everybody else's hands are. So there's the dealer up card, the number of the cards in deck, player ID to hand, which will include your own hand. And is that it? Is that all you need? Number of cards in deck, the dealer up card. Let's put this one above this. Information available to a player. So dealer up card, player ID to hand, num cards in deck, and then game rules as well, right? So public game rules. There we go. So basically they should be able to know the name of the game here. Up card, player ID to hand, number of cards in deck, and then the rules of the game. Isn't that everything they need? Or is there anything else that they need? I think that's it. All right, there we go. Cool. So let's go ahead and make a constructor here. So card, dealer, up card, iDictionary, int hand, player ID to hand. Let's go ahead and put these on their own lines here, so it's a little cleaner here. Int num cards in deck and game rules. Tunnel snakes rule. All right, so equals dealer up card equals player ID to hand. Capitalize that shit. So it's camel case. Equals num cards in deck equals rules. There we go. Okay, cool. Good stuff. So, this is the game view that each player is going to get, and they'll get past this when they're asked to make a decision. So let me go back to the player now. And this will take in game view. And that should be it. So gets the action the player takes. The view of the game. And then returns the action the player takes. I'm trying to think. There's nothing else. Ooh, wait. One thing, though. One thing. Game view. This needs to be hands. Because a player can split and have multiple hands. So let me go ahead and rename that. Player ID to hands. Let's rename this. Player ID to hands. And this needs to be an I list of hands. So I list of hands. There we go. Okay. Because you can have multiple hands for a player, so this is going to be a mapping of the ID. Excuse me. Jesus. It's fucking coffee, dude. A mapping of the ID to the list of hands the player is going to possess. Okay, here we go. I've been going for about an hour, but I'm kind of getting into it, so I might continue on a little bit longer here. Let me comment this out here real quick. The face-up card for the dealer. This one will always be available. Yeah, that makes sense. Basically, we'll get all the actions from all the player. The only time that we're using the game view is an output or what we're going to be giving to the player. All right, and then this is going to be a mapping from player ID to all of those that player's hands. The number of cards remaining in the deck and the rules of the game. Alright, so in that case, we could probably make this, so let me go ahead and put some of this shit in game state. I'm just wondering if I need to even have this game state object then. Probably not. I'll come back if I need it. I think it's fine. I think there's few enough components that it should be fine here. This can also be private because we'll just return, well, I mean, it doesn't matter. The public game rules, that should be fine. So private shoe. Ooh, but what about the cut card position as well? For the counter to know. Does a card counter need to know when the cut card is coming up? Or do they just need to know if the deck was shuffled? I don't know, we'll come back to that later. I think for now it's fine. Alright, so private shoe. I'll put the actually I'll put the cut card in the game rules anyway. Yeah, let's go ahead and do that. Alright, so private shoe. Although, what if I want to randomize the cut? I don't know, we'll get to that. We'll get to that when we get to that. Okay. Private shoe. Keep saying shoe. My favorite band. Yeah, let's do this. So, private iDictionary, or I guess we should just use a dictionary. Dictionary, int, list, iList, hand, player ID to hands. There we go. So we have the shoe, we have the hands. We should do the dealer hand as well. So, private hand, dealer hand. Right? Actually, that doesn't need to happen. No, we don't need to keep that as a property up here. This dictionary, actually that can take place all within the game logic. Well, maybe not. Let me just think here. How do we want to do this? So if I wanted to, let me just think about future-proofing here. If I wanted to hook this up to a view, like theoretically down the road, I would maybe want to write a UI for this so that we could kind of see what's going on. How would I want to hook this up? I could generate the view from the game view, but not really, because I would also then need to take the, I would need to potentially render what's going on in the game state. So maybe I should have a game state object then. That would potentially be public and could be exposed to a view, in which case then I'd have the dealer hand, and the dealer hand should always be around. Yeah, okay, fuck it. I might as well toss it into a game state object. I can change it later down the road if we need to. Alright, so there we go. So, game, public, class, game state. Let's go ahead and make this all public then. We'll have the random object be in the game because it's not really part of like the game state, really. So we're going to have public shoe, which you can get, and set. Yeah, because this is going to be the game state. Yeah, that's fine. Alright, so, player ID to hands. Get set. Because we won't be passing this to the player, we'll be passing the view to the player here. Dealer hand get... Whoops. That's not what I wanted to do. Get set. So this has the shoe, all the players' hands, the dealer hand, and... oh yeah, I should take in bets too. Oh, that's the other thing, that's the other thing. Okay, so... Player should be... should have a money amount. Okay, so int bankroll gets the bankroll of the player. Should have an ID, should have a bankroll. So yeah, I said I wasn't going to keep state in the player, but like that transcends a round-to-round sort of state. So there'll be like all of the game state. This is kind of like I am a player, I have a certain amount of money. So that should reside in the player. Okay? So there's a bankroll, but we need to have a get bet amount. Now the bet is going to happen before... The bet is going to happen before the cards are dealt. What are they going to make that decision based off of? Well, a card counter would make it based off of their internal card count. I'm just wondering if we want to pass a game view, right? Because we're passing back the number of cards remaining in the deck. The card counter would use that to establish a true count. Do I want to make the card counter responsible for keeping track of the shuffle? The thing is, like, the reason I'm asking this is because when we're doing the bet, things like player ID to hands and dealer up card don't matter, right? Or aren't even there. They're not defined at that point in time when we're taking bets, right? So it's kind of like messy if I just pass in the game view then. So maybe instead I'll So okay, actually here's an interesting thing, right? Card counters, do you need to know... Is there a difference between... No, there's no difference between seeing what the other player's hands are and, yeah, okay, never mind. I don't think I need this view to be this crazy then. So I could even maybe just get rid of the view. Does need to know the rules of the game, though. So, okay, this view, actually... I'm gonna make it so that the card counters need to keep track of the number of cards remaining in the deck. So I'm gonna get rid of this. Well, nah, it's fine. We can put it in. It doesn't matter. I'm gonna make it so we only take the hands. So basically, you don't need to know about anybody else's hands. So let's go ahead and do this. So, list hand... hands, which will get... this, we'll just do this. So list hand hands. Alright, and this is going to equal hands. Now the other thing too, actually... Yeah, wait, no. This should be... There we go. Okay, now this is what I need to do. This should be for a particular hand. Yeah. Because we need to go through each hand. So we'll be taking this one at a time. So hand, dealer up card. This is basically just going to be all of the parameters that we pass to the player to make their decision. So there's the deal. I'm going to put this in the structure so I don't have to keep like updating those parameters. So maybe I should even move this to the... Maybe I should change this. All right, so let's change this to player decision information. Sorry, I'm moving things around. Player decision information. I'm going to move this into the player folder, actually. Player decision information. It's going to be hand get public hand. There we go. So public hand. Represent, or sorry, the player's hand they are taking action on. So the dealer up card, the hand, the number of cards remaining in the deck. That's what I'm wondering though, is do I need that to be passed in, or can the card counters just keep track of that shit? I think, yeah, I think the card counters can just... I can handle that in the notify method. So let me get rid of this for now. The game rules... Yeah, I mean, the player should know that. So basically, it'll be dealer up card, your hand, the one that you're acting on, and then the rules of the game. Passing that in so that we don't have to have like a static pointer to... We don't have to have a pointer to the rules at all times. All right, there we go. So let's go ahead and get rid of this then. And the player is going to take in the player decision information. Let's rename this to player decision info. Relevant info for making decisions. There we go. Okay, now, before we even do that though, int get bet amount, which, I'm trying to think, that will just be, so for like everybody else that can just be like arbitrary, because there's no reason to, if you're playing like basic strategy, there's no reason to really vary your bet amount other than basing it on your bankroll, or if you just have natural variation. If you're doing card counting, you're going to adjust that based off of your own count, which is going to be state within the player. So I don't think I need to pass anything. So gets the amount to bet for a given round. There we go. Returns the amount bet. Alright, there we go. So we got player decision information there. We're going to have our game state here. Shoe, player ID to hands, public. I need this to be public. Public. And now the question is... okay, so this is going to be the state within the game. The thing is, what do I want to do with this? So I'm just trying to think of like how I would want to structure this down the road. So I'm spending a lot of time on this kind of shit, but this is stuff that's going to impact things a lot. I've talked about this before, but really with like coding, it's a lot about defining things specifically. So to have like an organized code base, you need your naming convention, where things land, where things reside, the flow of data. That's all very important to the hygiene of your project. And here's the thing is like, especially with this card counting shit, I really want to make sure I get it right, you know? And I want this code to be clean, readable, and auditable so that when I make claims, people can go to my GitHub and they can read through it and see exactly how I did everything, right? And so I want this to be good. That's what I'm getting to, so I'm spending some time with it. All right, so here we go. Let me think about this. So we got game state, we got our shoe, all this shit. Dealer hand. I'm just trying to think. if we need to do this, this will exist. Dealer hand is just going to be on a round-to-round thing. I'm just trying to think. Once again, the reason that I'm thinking about it like this is that there's a high probability that I'm going to want to make some kind of UI for this. And if that's the case, I need to be returning all of the data structures to the view. So what I could do is I could have everything be private within the game and then have a view function that would specifically return the view to the UI, and then that would guarantee, I could guarantee then that the UI cannot mutate the game state, and that might be the way to do it, actually. So maybe I'll just come back to this then. So let me see, there's the game here. Sorry, I keep waffling, but that's okay. So I'm gonna do this, So yeah, let's go ahead and do that then. So I'm gonna just follow like a model view controller pattern here. So the shoe will, basically everything out here is going to exist round to round, right? Player ID to hands, does that need to exist round to round? No, actually. No, it doesn't. So let's get rid of that then too. The shoe will, and the players will. So let me get rid of this game state. I keep creating the game state, getting rid of the game state. It's all good. Ultimately, like, a lot of this shit would be avoided if I just planned things out ahead of time. We're gonna make this private. Privates. This actually can be private too. So this, let's just do it like this. So, shoe. I'm gonna keep everything private until we need to expose it. So, public, private game rules, rules. There we go. So we have our shoe, we have our game rules, and then I should have a list of players, right? Yeah. So private iPlayer, or list of iPlayer players. There we go. So random R, we have the shoe, we have the rules, and we have the players. And that should be it, I believe. Yep. Okay. I'll add things later. I'm getting ahead of myself. But here we go. Alright, so what I want to do is I want to do a public game. It's going to take in a random R. It's going to take in game rules, and an IEnumerable of iPlayer players. Alright. I mean, eventually, potentially, players might swap in and out based on their bet amounts. Now, actually, here's the other thing, though, is do I really need that to happen, though? And do I need to keep track of a bankroll, or could I just keep track of, like, a delta? So maybe I'm going to rename this to, profit. Because I don't care about people getting wiped out and shit. I just want to see the change. I mean, okay, but maybe... But we could use that. Yeah, that should be fine. That should be fine. So, gets the change in bankroll the player has experienced in the game. There we go. So now I don't have to worry about swapping in and out. I could maybe have... If I want them to stop, I could just have them stop playing. I don't think I'm going to need swapping logic. So we're just going to take a list of players. So random R, game rules, players. And then I'm going to say this dot R equals R. This dot rules equals rules. So this dot players equals new list player, iPlayer. And then for each var player in players, whoops, this dot players dot add player, and then what is this? Okay, well, there you go. All right, that's what the ID is for again. All right, here we go. So we got that shit, and then... Okay, now here's one of the first game rules I want to add, though, is public int numdex get... yeah, numdex. I'll figure out how I'm going to instantiate the game rules later, but for now, the game is going to get this. So, what I want to do now, and let's do this actually. So, I'm going to use one of these called shoeutils.cs over here. So this is going to be used to generate a new deck here. So public static class shoeutils. Utility functions relating to the shoe class. And this is going to be public static I list card generate shoe based on a certain number of decks. Alright, so var result equals new list card. Eventually we're going to return result, but let's fill in the middle here. So, here's what we're going to do. So, for int I equals 0, I is less than num dex I plus plus. So for each deck, we're going to do the following. So for each var rank in, what is it, enum dot value get values of rank rank, right? What is it? That's just let me see here. Type rank, which is okay. So what is this? Rank. What is this? What is this complaining about? Rank is a type which is not valid in the given context. Get values enum type. I thought that's what you're supposed to do. For each statement cannot operate on variables of type rank because rank does not publicly get numerator. Oh, wait. Is it, there we go. Wait, so what is this complaining about? Rank is a type. Change to... Just a sec. I'm trying to remember how to fucking do this. Sorry. Brain fart. So, C# enumerate through enum. Get values. Oh, right. Rank. What? Where is it? Oh, right. I don't pass it in. There we go. Okay, there we go. So I don't need to do that shit. And this is var enum. Okay. So now what I want to do is no, I do want to do that actually. So I want to have the cast there. And then now we should be going through rank there. Yeah, okay. Okay. I think that's good. Sorry, I got a little brain fart there. So now for each var suit in I enumerable suit enum dot get values of suit result dot add new card rank suit. There we go. Alright, so just to make sure that this isn't fucking up, let me just test it out real quick. Here we go. Var shoe equals new, or no, let me just say var cards equals shoe utils dot generate shoe. Let's just do 2 for now. And then for each card in var card in cards console.writeLine card. Let's try that out. There we go. Alright, so 2 of clubs, 2 of diamonds, 2 of hearts, 2 of spades, blah 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 blah, ace of clubs, blah blah blah. Okay, we're good. Okay, I really wanted to make sure just compiled, that's all I really wanted, but there we go. Alright, because I wasn't sure if this cast was gonna fuck something up, but it's all good. Alright, so we generated the shoe, so I'm gonna say, generates all of the cards for a shoe. Let me call it generate shoe cards instead. Let me rename because I used it in that thing. Generate shoe cards. Okay. For shoe, number of decks, the number of decks to use, returns a list of all cards to put in the shoe. Alright. So there we go. So we got generate shoe cards from a number of decks. The game is going to, so this dot shoe equals, or sorry, this dot shoe equals new shoe, shoe utils dot generate shoe cards from this dot rules dot num decks. There we go. All right, so we've got our random number generator, we got our shoe, we've got our rules, we got our players. Okay, I'm probably going to wrap this up pretty soon here, just because it's getting pretty long, but hope you've enjoyed. Let me just see if there's anything else I want to do. I think that's good for now. I'm going to call it stop here. I might continue to work on this in a new video, but I just want to, you know, stop it now. We're almost at like 2 hours, I think, so, or like an hour and a half. I don't know. I stopped recording before and took a bathroom break, so who knows, but yeah, let me know if you'd want to see more of this shit. I love coding. It's lots of fun, you know? Let me know if you have any questions or recommendations about what I'm doing, but so far we have got our basic data structures, our basic scoring logic done. We're getting the structure of the game set up. I'm trying to future-proof it so that if and when I want to put on a visual like UI, I can do so and kind of plug and play pretty easily. And then I'm setting it up so that the players can make decisions based on the game here, you know, and get actions and things like that, so I can implement different strategies, yada yada yada. But yeah, so first step is I just want to get the game going and working so that you can play a game of blackjack with a bot, a player. Then I'm going to move into generating different strategies. So I'll try to make it so that I can compute basic strategy, okay? Then I will implement card counting strategies on top of that, see how they do, and I can start analyzing them. And then after all of that's done, I may implement some kind of a UI. So I think that's the main process. I think I made reasonable progress here. I mean, I'm kind of getting the low-hanging fruit out of the way, but that's kind of how you got to do it, man. Just deal with the things that you're pretty sure about, and then move into the things that you're a little more unsure about later. But let me know what you thought. Hope you had a good time watching. All right, I'll talk to y'all later. Bye-bye.